So here's the question. There are two parts, parts A and B. Fairly short question and only 4 marks, 2 marks for each part of the question. As always, I would recommend that you read the question through thoroughly. It's a good idea to train yourself to read each question through 3 times before you start it. That reduces the chance of missing anything. Okay, what's the question about? Well, let's focus on the part A of the question. And pretty clearly, they're asking us to expand an expression. In other words, to remove the brackets from an expression. Not only that, but they're telling us how to do it. They're telling us to use the binomial theorem. That's a big clue straight away. If we don't know what that means, we won't be able to answer the question. We won't be able to access any of the marks for this question. It's worth just looking ahead to part B before we even start part A. The keyword here is hence. That means that the examiner requires us to use our answer to part A in part B of the question. Okay, there's a very, very clear link. Right, starting with part A. As I've already suggested, we need to remember the binomial theorem. In the case for part A and for part B, the exponent is 4. Okay, so it's a bracketed expression, binomial expression to the power of 4. So at this stage, what you should do is just put the question to one side and write down the appropriate version of the binomial theorem. Okay, and in the usual way for the binomial term within the bracket, use the letters x and y. So x plus y in brackets to the power 4. And at this point, you're going to have to remember how this bracketed expression, the one on the lower line here, expands. I would suggest you do this in 3 steps. Step 1, write down what the powers of x are in each of the expressions in the expanded binomial expression. So you should remember that the powers of x start with x to the power 4 and decrease 1 by 1, x cubed, x squared, x to the power 1, all the way down to x to the power 0. Okay, write all the powers in, even the power 1 and the power 0. And if you're writing this by hand, you should have left a bit more space in between the terms than I have done here. Now, I'm going to write in the appropriate powers of y. I've highlighted those in red. So the powers of x are as they were before, x4, x cubed, x squared, x to the power 1, x to the power 0. And I've slotted in powers of y. Powers of y are in increasing order, from y to the 0 up to y to the power 4. Notice that in our expanded version, we've got 5 terms. In the binomial theorem, when the exponent is 4, you will definitely have 5 terms in your binomial expansion. Okay, we've done the powers of x, we've done the powers of y. There is one more component to put in, and that's the binomial coefficients, the numbers in front of the powers of x and y. So you should know that the coefficients in the case of exponent 4 are 1, 4, 6, 4, 1. That's the 4th row in Pascal's triangle, or I suppose the 5th row if you count the top row as just 1. Remember, you can always work out what the numbers in any row of Pascal's triangle are by writing out the first few rows of Pascal's triangle. Okay, I'm just going to tidy up this expression on the right hand side here. Where I have a coefficient of 1, obviously I don't need to write that. Where I have an exponent of 1, I don't need to write that. And where I have an exponent of 0, I remember that anything to the power of 0 is just 1. So just doing that little bit of tidying up, I get this. Okay, and that's our standard binomial expansion for exponent 4. Okay, you could, if you like, just write that down. If you're pretty handy at remembering these things, you could have just written that last line down. But if you don't, I've indicated to you how to construct it. Right, moving on. We're now going to apply this expansion for the expression in part A of the question. Okay, here's the standard binomial expansion for exponent 4. So for part A of the question, looking at what they have inside their brackets in the question, I need to replace x with a and y with square root b. Okay, so we can just do that. So in my line, my standard binomial expansion, I'm going to replace x with a and y with root b. Whenever you make a substitution into an algebraic expression, I would strongly advise you to use brackets, whether or not the values or the terms that you're substituting are positive or negative. Okay, hopefully this is a habit you've adopted for GCSE. You may have got away with this a little bit at GCSE, but bear in mind this is A-level now. It's going to be a whole lot trickier, a whole lot more difficult. Okay, and the way to avoid making mistakes is simply to take more care with your algebra. It's not rocket science, it's really straightforward. So here's one of the good working habits, is to use brackets whenever you substitute anything, numbers or expressions, into an existing expression. Okay, so you can see I've replaced x with a and I've replaced y with square root b. It looks a little bit messy because there's a whole load of brackets around. Now, in order to tidy up, to get my final version of the answer, I need to get rid of the brackets. It will end up looking like this. Let's backtrack a little bit here and let's see how the removing brackets worked. We'll look at the binomial expansion term by term. Remember, there are 5 terms on the right hand side here. So it should be clear to you that I can remove the brackets in this term. Bracket a to the power 4 is just a to the power 4. Nothing bad will happen if I just get rid of the brackets altogether. Okay, now focus on the next term, a little bit trickier. But again, you should be able to convince yourself that I can remove both of the pairs of brackets there without any problem. Moving along to the third term. Okay, here's where it starts to get a little bit trickier. Not very tricky, but we need to take care. The examiner is expecting us to do something in particular here. The a term is fine. I can remove the brackets around the a and it won't change anything. But remember that square root of b squared is just b. Square root of b, all squared, means square root of b times square root of b. You should know that that's written in its most simple form as b. Okay, trickier again is the next term in the expansion. Look carefully. Again, all I've done is I've removed the brackets around the a term, and then root b, all cubed, has mysteriously become b root b. Why is that? Well, root b, all cubed, is root b times root b times root b. And remember, root b times root b is b. So I'm left with a b root b. Okay, have a think about that. Make absolutely sure you understand where that comes from. If you need to, put in an extra line of working out. If in doubt, always show more working out rather than less working out. Again, that's one of the basic working habits of algebra. Last term, again, you might find this a little bit easier, or it might be a little bit elusive for you. Root b to the power 4. That means root b times root b times root b times root b. Every time I have a root b times a root b, I have b. So I end up with b times b, which is b squared. So there we go. On the bottom line here is the final answer for part A of the question. Not a particularly elegant expression, but that's what the examiner wanted. Now I've spun it out a little bit. I put in quite a bit of explanation there. Again, you may be a little bit frustrated. You're only being offered 2 marks. But as far as the examiner is concerned, binomial theorem is a fairly basic bit of A-level algebra. Okay, we're now ready to have a look at part B. Remember that there was a key word here, there was hence. We need to use our answer for part A. Now, in one sense, this is fairly obvious because the expression that we're being asked to look at is two bracketed binomial expressions, the first of which is the same as the expression in part A of the question. So all we need to do at the moment is to look at the second bracketed expression in part B of the question. So what I've written down under the heading step 3 here is, this is the basic binomial expansion for exponent 4 again. This time we need to do this substitution. We need to replace x with a and y with negative root b. So let's do that. Again, the first time you write this down, make sure that you use brackets. I'm sure that most of you will remember when you're substituting negative numbers into an expression, this is a standard technique. Put brackets around the negative numbers. It'll avoid silly errors like, squaring a negative number. It'll avoid silly BIDMAS errors, BODMAS errors, and things like that. But even though we're doing A-level here, don't forget your GCSE habits. And again, if things start to go wrong, what you have to do in maths is you've got to peg it back a bit. You've got to take yourself back a notch and go back to some earlier working habits. Okay? So again, the examiner would like me to remove all the brackets and simplify this expression. Some of you are probably absolutely fine with doing this straight off. So I'll just jump to the answer straight away, just for the moment. We should get this. Again, if you're not sure, we'd like a bit more explanation. Here it comes. Again, we'll look at it term by term. The first term, the a to the 4 term, it's fairly obvious that I can remove the brackets straight away. That's the same as before. So let's move on to the second term. And the only difference here is the bracket negative root b. When I expand the bracket here, I would put the negative symbol at the front of that expression. So 4 times the cube of a times negative root b will become negative 4a cubed root b. In algebraic expressions, we always put the sign first, then the numerical coefficient, then the algebraic components. Algebraic components, by the way, would often be written in alphabetical order here, but there are certain other rules that apply in other questions. Okay, as usual, if you want to pause the video at this point, that might not be a bad idea. Just make absolutely sure you understand where that step has come from. Now let's move on to the next term in the expansion. Again, we understand the 6 and the a squared, that's fine. Think about the square of negative root b. That's negative root b times negative root b. Well, again, do the sign first. Always do sign, number, by which I mean numerical coefficient, and then algebraic expression. So you know that negative squared makes positive. Hence I get a plus sign. And root b times root b, again, is b. So this term is plus 6a squared b. Okay, next term, remember it got a bit trickier. Again, the 4 and the a are fine. This is now, we're looking at the cube of negative root b. Well, a negative cubed, that's negative times negative times negative, definitely gives a negative. Okay, odd powers of negatives give negative, even powers of negative give positive. And exactly as before, root b cubed, that's root b times root b times root b is b root b. Last term, if you're following this, the last term should be fairly straightforward, again a little bit easier. The 4th power of negative root b, a negative to the power 4 is plus, positive, and root b to the power 4, exactly as before, is b squared. Okay, so the bracket expansion here again is what's shown on the bottom line here. Okay, we have so far done two binomial expansions, one for part A of the question, one for part B of the question. They are very similar and differ only in a sign. Okay, so let's put those back up together. Here again, have a think about presentation. It's well worth writing out these two binomial expansions again carefully, lining them up neatly, one above another, exactly like I've done here. In algebra, and this is more and more true as you go to more and more advanced algebra, how you display things, how you set things out is hugely important. An awful lot of student mistakes are down simply to careless presentation. Okay, so what I am asked to do is give an expression for the sum of the two left-hand sides here. Okay, so all I'm going to do is to add the two rows I've got on the screen here. Okay, so adding the expressions on the left-hand side gives me what I'm asked for in the question, and then carefully adding the right-hand sides gives me this. And again, what I've got on the bottom line here is the final answer, but let's have a bit more of a closer look at it. Again, term by term, when I add the right-hand sides, adding those two terms, a to the 4 plus a to the 4, obviously 2a to the 4. Don't make a silly mistake and write a to the 4 plus a to the 4 equals a to the 8. Okay, the examiner needs to see that you understand indices. Next two terms, well, have a look at this. If we pay careful attention to the signs, and provided we haven't made a mistake with the signs so far, it should be clear that when I add these two terms, I get 0. One is exactly the negative of the other. So there is nothing in the answer corresponding to those two terms. Next two terms are both positive, so that's 6a squared b plus 6a squared b. It's obviously 12a squared b. Next two terms are a positive and a negative, so they exactly cancel each other out when I add them together. And last pair of terms, b squared plus b squared, is going to give me 2b squared. So the question has this sort of alternating feel to it, this plus minus, and then reinforcing, cancelling. You'll see that quite a lot in maths and possibly in other subjects like physics. And there's a certain sort of pattern thing going on there. Okay. So again, at the bottom of the screen here is my final answer for part B. That should be 2 marks for that. Let's review the core skills that we needed to get those 4 marks to answer the question completely. First, binomial theorem. The examiner needs us to demonstrate that we can write down the binomial theorem for any reasonable positive exponent. Okay, here it was exponent 4. Other questions might be exponent 3, maybe exponent 5. It's unlikely to be a very high number because the question would just be too cumbersome then. You've seen in a couple of the algebraic steps we needed to be able to manipulate powers and roots. For example, identifying that root b times root b is b and that root b cubed is b root b. If you're not quite sure about those things, you should go back to the surds part of the of Unit 1 and practice some manipulation of surds. One wouldn't really say that this question is about surds because we are not told numerical values for A or B. Another basic core algebraic skill is signs, dealing with signs appropriately. Again, it's amazing how often students lose mistakes just because they lose track of signs. So that's something to be aware of. Take great care of your plus and minus signs. And again, a lot of it is down to simply setting the work out on the page in an appropriately careful manner. Let's look at some wider skills, which we don't really need to know for the purposes of the question, but which you might be aware of. You should be aware that the binomial expansion also crops up in connection with probability in Unit 2 of the course. The expansion is exactly the same, but in that case the two terms inside the bracket, what I have as A and root B here, are probabilities. They're complementary probabilities in that case, which would add up to 1. That doesn't really apply in this question. It doesn't really have quite that structure. This question is probably a little bit closer, as I've already hinted, to the part of Unit 1 that relates to surds. There's a sort of hint in the question that we should be thinking of A and B as whole numbers, possibly with B not being a square number. So A and B are integers and B not square. In that case, the expansion that's the outcome of part A of the question leads to a surd expression, whereas the outcome that results from part B of the question would actually be, the answer, the expression on the right side, would actually be an integer. And in fact, it would be an even integer, if you'd like to have a think about that for a minute.